Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So as you all know, we have started a series where we are going to complete the entire syllabus of chemistry for your KCET 2025 examination, and we are also going to practice a lot of previous year questions and solve many questions, right? So I hope you are following this series. So today we are going to finish this most important topic, that is aldehydes, ketones and carboxylic acid. So today will be the last lecture of this particular topic or chapter. So in today's lecture we are going to discuss physical properties of carboxylic acid and the chemical reactions. Okay, so I hope and I request all of you to sit with a notebook and a pen so that you can note down all the reactions in a flowchart form and can revise them easily. Okay, and one more request, please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video. So you can download if you join our WhatsApp channel, you will get access to all these notes in the PDF format, and you can also get access to the mock test and the solutions. Everything is available in our WhatsApp channel, so please do not forget to join the WhatsApp channel. Okay, so now without any further delay, let's get started for today's class with chemical reactions and physical properties of carboxylic acids. Okay, so as I told you how we are going to cover this chapter, so this is very important, so that you should know, like when you are revising you can have a mind map. Okay, there were 4 parts. In this part we covered this one, this part, this one, so every topic will be in your mind and you can revise it very easily. Okay, so now coming to the first one, that is in the first part we already covered nomenclature, structure and preparation of aldehydes and ketones. In the second part we have done physical properties and chemical properties. In part 3, that is in the last class, we have done nomenclature, structure and methods of preparation. And in the part 4 we have done today we will be doing physical properties and chemical reactions of carboxylic acids. Okay, so now year-wise weightage, as you know, this chapter you can easily expect 3 to 4 questions every year, whether directly or indirectly, but the reactions of these chapters are almost there in 3 to 4 questions. Okay, so now before today we will be doing some revision of the reactions that we have studied in the previous class. Okay, so that means we have studied so many reactions, and the best way to practice reactions is to do conversion questions. Okay, so today I have brought up some conversion questions that we can do based on the reactions that we have studied in the previous class. Okay, and that will be a type of revision of the reactions that we have learned in our previous class. Okay, so now coming to the first one here, butane 1-OL to butanoic acid. So the first conversion is what? You have butane 1-OL. Okay, so butane 1-OL to butanoic acid. Okay, butanoic acid. So now if you see this one, this is the number of carbons is same, so it is directly the oxidation of primary alcohol to carboxylic acid, and we know primary alcohols are oxidized to carboxylic acid under strong oxidizing agent. So what are the strong oxidizing agent? You can have KMnO4, or you can have K2Cr2O7, or you can use CrO3 with H2SO4. Right, Jones reagent. So these all things can easily convert this one to this one. Okay, now coming to the second one, benzyl alcohol to phenyl ethanoic acid. So if I write the second one, you have benzyl alcohol, that means this is benzyl alcohol and it needs to be converted to phenyl ethanoic acid. Okay, so first of all we can convert this OH to any SOCl2. So this will give me what? If you remember, this reaction is from your alcohols chapter, right? And this reaction is also there in the haloalkanes chapter. So you see, in organic chemistry you need to have mastery over all the 4 chapters, or especially the first 3 chapters, that is haloalkanes and haloarenes, alcohols, phenols and ethers, and aldehydes, ketones and carboxylic acid, to do any question that comes in the exam, because generally question contains a mixture of reactions from these 3 chapters. Okay, so now after getting this one, we can just convert it into KCN, right? So I'll get CH2Cn, and then you can do hydrolysis, right? So this will give you CH2COOH. Now coming to for the third one, 3-nitrobromobenzene to 3-nitrobenzoic acid. So we have 3-nitrobromobenzene. So we have bromine, 3-nitrobromobenzene to 3-nitrobenzoic acid. Okay. So definitely you can see here this bromine is converted to COOH, but you know there is no reaction where directly this bromine can break from the benzene tree. So here we can use one thing, that is your Grignard reagent. So you can just take it first, treat it with Mg ether. Okay, so this one will give you NO2 group with MgBr. Okay, now once you treat this one with CO2 and H3O plus. Okay, so what will happen? This is plus, this is minus, this will attack here, and we will get this one. Okay, though it is 3-nitro, so I made it 4-nitro by mistake. 1 second. So it is 3-nitro. Okay, so here there will be nitro group. So we will get 3-bromobenzoic acid. Okay, so these conversions are there in your NCERT book also. So the examples in the NCERT book are very important. So please practice questions from your NCERT book first. Once you are done with that, in text questions, NCERT questions, then go for other questions if you want to practice further. Okay, fine. Now coming to the fourth one here, 4-methyl acetophenone to benzene 1,4-dicarboxylic acid. So first one we have here, fourth one, that is 4-methyl acetophenone. So I can write it in this way. 1 second. Okay, so we have 4-methyl acetophenone. So this is acetophenone, and we have 4-methyl acetophenone, and then you can just treat it with KMnO4, right? So KMnO4 will convert this one to COO minus K plus, and this one also COO minus K plus, and then just treat it with H plus, and we will get COOH here and COOH here. Okay, so that is your benzene 1,4-dicarboxylic acid. Now coming to fifth one, cyclohexane to hexane 1,6-dioic acid. So just cyclohexene is there. Okay, so here also you can just treat it with KMnO4 and H plus. You will get this compound as cyclohexane 1,6-dioic acid. Okay, so we will get like this. Okay, simple one-step reaction. And the sixth one, if you see, butanol to butanoic acid. So you have butanol, CH3, CH2, CH2, COH, butanol to butanoic acid, CH3, CH2, CH2, COOH. Okay, so this is just oxidizing agent. Any oxidizing agent you can take to get this one, right? So simple oxidation, you can do it with CrO3, H2SO4, or KMnO4, or you can do K2Cr2O7. Okay, so these oxidizing agents will convert aldehydes to carboxylic acids. Okay, so I hope we have just have a brief revision of all the reactions that we have studied. Now we'll go to today's topic, that is physical properties of carboxylic acids. So under physical properties, first of all we'll talk about their boiling point, and then we'll talk about the solubility. So in boiling point, so the carboxylic acids have very high boiling point, okay, than even aldehydes, ketones and alcohols. Okay, now what is the reason for that? This is because of intermolecular hydrogen bonding. So if you see the structure of carboxylic acid, okay, so this oxygen lone pair can form hydrogen bonding, and this hydrogen can also form hydrogen bonding. So there is extensive hydrogen bonding in the carboxylic acid, due to which their boiling point is very high. Okay, Now coming to solubility, the solubility decreases with the increase in the number of carbon atoms. So that is there. If this R group increases, okay, if this R group will increase, then solubility will decrease, right? Now higher carboxylic acids are practically insoluble in water due to the increased hydrophobic interaction of hydrocarbon part. So if this R group is smaller, then it is easily soluble, but if this R group is very big, long chain of carbons are there, then it is not soluble. Okay. Now coming to, okay, now we'll talk about the chemical reactions of carboxylic acid, the most important topic. So first of all, this reaction is categorized into 4 types. Okay, so the first one is the cleavage of OH bond. Like if you remember, in the alcohols reactions also we studied reactions where there is cleavage of OH bond and there is cleavage of CO bond, right? So similarly here, first of all, cleavage of OH bond, and next we have cleavage of CO bond reactions. Then we have the reactions where COH, the whole group, is involved, and the reactions involving in the hydrocarbon part. Okay. Now coming to here, in the cleavage of OH part, we will be studying about the acidic nature, very important, and we will be studying about the reactions with metals and with alkalis. Now coming to cleavage of CO bond, here we will be studying about anhydride formation, esterification, and reaction with PCl5, PCl3 and SOCl2. Okay. Next coming to reactions involving, okay, one more is there, reactions with ammonia. Then coming to reactions involving COOH group, here we will study about reduction reactions and decarboxylation reaction. Next coming to reactions involving hydrocarbon part, here we will be studying about halogenation and substitution. Okay, so let's again revise the complete table. We have 4 types of reactions here. First, reactions involving the cleavage of OH bond. Under that, we will be studying about the acidic nature of carboxylic acids and about the reactions with metals and alkalis. Next, there is reaction where there is cleavage of CO bond. Under this, we have anhydride formation, esterification, then we have reactions with PCl5, PCl3 and SOCl2, and then we have reactions with ammonia. Next, we have reactions involving the whole COOH group. So here we have reduction reactions and decarboxylation reaction. Next, we have reactions involving the hydrocarbon part. So here the first one is your halogenation and the next one is electrophilic substitution. Okay. So there are 4 categories. Okay, so we'll go one by one category. The first one is the cleavage of OH bond. Under that, what are we going to discuss? Acidity and reactions with metals. Okay. So cleavage of OH bond, first we'll talk about the acidic nature. So here if you see this one, carboxylic acids are more acidic than phenols. Okay, the carboxylic acids are more acidic than phenols. Now what is the reason for this? Now if you see the carboxylic acid, okay, we have like this. Okay, now after giving H plus, this will be the conjugate base. Now this conjugate base can resonate to give you this structure, right? This will be the structure. Now in phenols, if you see the phenol resonating structures, if we used to draw, it was like this, O minus, this bond will shift here, this one will shift here. So I'll get here O double bond, and here it will be minus, right? Now if you see here, the negative charge is coming on a less stable atom or a less electronegative atom, that is carbon. But in the resonating structure of the conjugate base of carboxylic acid, the negative charge is always on the highly electronegative atom, that is oxygen. So that is why this resonating structures are more stable than these resonating structures. Why? Because here negative charge is on oxygen, where in case of ours, in the case of acids, right? And in phenoxide, in phenols, so I'll write it as AR. Okay, so if I write it as AR, okay, here the negative charge is on carbon, right? So that is why this phenoxide ion is less stable and this is more stable. If the conjugate is more conjugate base is more stable, then the acidic nature will be more, right? So that is why I can say that this is more acidic. Clear? So I'll erase this resonating structures. Okay, so now next one, in the conjugate base, okay, if we have electron withdrawing groups, then acidity will increase, and if we have electron donating groups, then acidity will decrease, right? This all of you know. We have already discussed this in the alcohols part, phenols part also. If electron withdrawing group is there, it will increase the acidity. Now, what is the order of electron withdrawing groups? So, first is CF3, then NO2, CN, F, chlorine, bromine, iodine, then pH. Okay. So, CF3, then we have NO2, CN, then fluorine, chlorine, bromine, iodine, and then lastly we have phenyl ring. Okay. So, now I will be telling you a order of the carboxylic acid. So, you can see here, this is COH group. Let me take a different pen. Yeah. So, now you see this is COH group, and here I have CF3, which is an electron withdrawing group. Now, CF3 is CCl3, as chlorine is less electronegative, fluorine is more electronegative, fluorine will be a better electron withdrawing group. Next we have, so out of now three halogens we have, now we have 2 halogens. So, again we have chlorine, and then we have, okay, so with halogens this part is over, right? CF3, Cl3, and then CCl2. Next you see we have NO2 group, okay. After NO2 group we have here CN group, okay. Now, next one if you see, again we have now only fluorine group, then we have chlorine, then we have bromine, fluorine, chlorine, bromine, okay. After that we have only formic acid, right. So, after that you can see here we have 1, 2, 3, on the third carbon chlorine is there, here there is phenyl ring, next you have again phenyl ring, here you have no other group, and here also no electron withdrawing groups. So, as the electron withdrawing group is there, the acidity will be very high, okay. Now, coming to the reactions with metals and alkalis. So, whenever there is a cleavage of OH bond, so these type of compounds can react with metals and with alkalis. So, that reactions we will see here. So, you can see here, this one can react with Na, okay. So, we will get RCONa, and this hydrogen will give you H2. Now, if it is reacting with NaOH, so we will get RCOO plus, and then we will have H2O. Then we have NaHCO3, so we will get RCO minus Na plus, and then we have H2O, and here it will be CO2, okay. So, if you see the phenols or the alcohols do not react with NaHCO3, but acids can react with NaHCO3. That is the difference that you must remember. What I said, alcohols do not react with NaHCO3, no reaction, but carboxylic acids can react. Clear? So, 3 reactions. So, we are done with cleavage of OH bond. First, we understood about the acidity. Here, you should remember that the electron withdrawing groups will increase the acidity, first thing, and the next one is reactions with metals and alkalis. Okay, fine. Now, coming to the next one where there is cleavage of CO bond. Under this, we had 4 reactions, right? First is, if you remember, tell me, first one is anhydride formation. Then we have esterification, right? Then we had reactions with ammonia, and one more was there. What was that? One more reaction was there, reactions with PCl5, PCl3 and SOCl2. Okay. So, we will go to the next one. Okay. So, here we have anhydride formation, esterification, reactions with PCl3, PCl5 and SOCl2, and reaction with NH3. 4 reactions we have, right? So, we will see them one by one now. So, if you see the first one, the first reaction is your anhydride formation. First reaction is anhydride formation. So, you can see these 2 carboxylic acids are reacting, okay. Anhydride formation happens with the removal of water, okay. So, what happens here? This H2O is removed, okay. Now, this oxygen and this carbon forms a bond. You can see this oxygen is there and this carbon forms a bond to give you this one. So, this is your first reaction, that is anhydride formation, okay. So, next reaction, if you can see, this is your second reaction, that is esterification. Esterification. So, in this reaction what is happening? If you can see, as the name suggests, cleavage of CO bond. So, here there will be cleavage and here there is OH cleavage bond, and this water molecule is removed. So, what I will get? RCOOR dash plus water, esterification, okay. Now, the third one is your reaction with reaction with PCl5, PCl3 and SOCl2. Okay, so if you can see here, if you take PCl5 here, the byproducts are very important. PCl5 if you take will get ROCl plus POCl3 plus water. Okay, now if you take PCl3 will get RCOCl plus H3PO3. Now if you take SOCl2, as you remember this reaction, here chlorine will be formed and SO2 gas, HCl gas is formed. Okay, so this is the third type of reaction. Next, the fourth reaction. The fourth reaction was, if you remember, was reaction with ammonia. Reaction with ammonia. So this is also very easy reaction. See, first of all, what happens? This is an acid, right? So this one will give you O minus and H plus. This H plus is taken by ammonia to get NH4 plus. So we'll get CH3CO minus and NH4 plus. Now once you heat it, there will be a removal of water. So this oxygen and this 2 hydrogen will be removed from here. So what will be left? 1 nitrogen and 2 hydrogen. So that is you can find out here. Okay, so I can write it like this: OH2 NH2, right? So now this part will go and we are left with CONH2. Okay, so this compound that is formed is called as the amide. Okay, so this is the formation of amide. Now let us practice 2 more questions like this. Okay, so now you see, first what will happen? This one will donate H plus and this one will accept H plus. So here there will be a salt formation. So what will be that salt formation? We'll have CH3, then we will have CO, and then we will have here O minus, and I am writing this NH4 like this. Can I write like this? NH2H2. So this is actually NH4 plus only, but I am writing in this way to make you understand about the dehydration part. So what will happen now? This H2O will dehydrate, and then I'll get here this one C double bond O NH2. Okay, another benzamide will get. Now if you solve this question, this is very important question. Here what will happen? We'll get the same thing. So I'm writing now directly. We will get finally CONH2 here. Okay, and we'll get C double bond O NH2 here. Okay, so now what happens? In this part there is removal of NH3. Okay, so one NH3 is removed. So what will happen left now? So we will be getting here C double bond O NH and C double bond O NH. This compound is called as phthalimide. Okay, so this is very important question. So you can note down, this one is an important reactions. Okay, please note down this reaction. So now we have seen with the cleavage of CO bond 4 reactions. First one is anhydride formation. Okay, second one is reactions with, the second one is esterification. The third one is reactions with SOCl2 or your PCl3 or PCl5, and the fourth one is reaction with ammonia, and there this reaction is very important where there is the formation of phthalimide. Okay, fine. Now let us go to the next one, that is reactions of COOH group, means those reactions where the complete COOH group is involved. So here the first one is reduction and the next one is decarboxylation. Now reduction, if you have already, this reaction we have already studied in the formation of alcohols and all. So if you see, we have RCOH, we can reduce that using lithium aluminium hydride or B2H6. Okay, these are the 2 reagents that you must use. You cannot, so remember here, you cannot use NaBH4. Okay, so we can use lithium aluminium hydride in presence of ether and H3O plus, or you can use B2H6. Okay, so this one will give you, so this part, if you see this part, this carboxylic acid part gets converted to alcohol, right? We'll get this one. Next, coming to decarboxylation reaction. So this one, if you see NaOH and CaO, this is nothing but soda lime, right? NaOH and CaO is nothing but soda lime. right? So RCONA, and in presence of NaOH and CO, what will happen? There will be decarboxylation and there will be formation of alkane. Okay, so this is the reactions under where the complete COH group is involved. So you can see here also the complete COH group is involved, here also COH group is involved, right? So for reduction, which reagent we can use? LiAlH4 or B2H6, and for decarboxylation we will use NaOH and CaO, that is soda lime. Okay, so next, coming to the next reaction, that is reactions involving hydrocarbon part. So under hydrocarbon part there is two reactions, that is your halogenation and substitution. Now the first one, halogenation reaction. Okay, here I will write halogenation. This is very important reaction, halogenation reaction, and this is very important. Okay, now see, halogenation reaction happens in those carboxylic acids where there is the alpha hydrogen is present. Now what is this alpha hydrogen? So if you see this carbon, this is the carbon having the functional group, so this is the alpha carbon, and this hydrogen is called as your alpha hydrogen. So in those type of acids where there is alpha hydrogen, if you react it with X2 in presence of red phosphorus, this hydrogen is replaced with X. What can be X here? Cl or bromine. Chlorine or bromine can be taken. Now this is a name reaction, and this reaction is called as HVZ reaction. What is it? This Helmholtz-Zelinsky reaction. Zelinsky. Okay, HVZ reaction. So what is there? What two things you need to remember? First is the presence of an alpha hydrogen is mandatory, and the next thing that you should know is the reagent X2 red phosphorus in presence of water. Okay, next coming to here electrophilic substitution reaction. So here again two things that you should remember, that COH group is a electron withdrawing group. If it is an electron withdrawing group, then it is meta directing group, right? So now if you see, we have COH group. Okay, if you take concentrated HNO3 and concentrated H2SO4, then what will happen? NO2 group will be added at the meta position. Okay, next if you take Br2 FeBr3, bromine will be added at the meta position. So this is what? This is your halogenation reaction, right? And this one is nitration. Okay, so we'll get NO2 group and Br group here. Okay, so we are done with the fourth type of reactions. Now we'll go to the first slide where we have seen all the reactions, and then quickly we will revise that. Okay, so yeah, this slide. So here is the slide where we will revise everything. So under acidic nature, we have seen that electron withdrawing group will increase the acidity. Under reactions with metals, three reactions we saw: reactions with Na, NaOH, and reaction with NaHCO3. Right, this is the first thing. Next, for anhydride formation, there is dehydration. You can use anything like H3PO4 reagent. Here for esterification, simply you have to use H+. Reactions with PCl5, PCl3 and SOCl2, that is there. And here in NH3, what is the important one that we studied? Reaction with phthalimide or the formation of phthalimide. Okay. Next, in reduction, what is the reagents that we will use? We can use LiAlH4 or B2H6. Then in decarboxylation, we will use NaOH and CaO. Next, under this one, halogenation, we can use for halogenation X2 FeBr3, and for nitration we have halogenation, this is different one, that is your HVZ reaction, right? So here what is the reagent required? We have X2 with red phosphorus, and for substitution we can use concentrated, for nitration you will use concentrated HNO3 and concentrated H2SO4. That is the first thing. And the second one we can use is X2FeCl3. Okay, so this is halogenation and this is nitration. Okay, so done. Okay, now we have completed all the reactions that we have discussed in this particular chapter. Okay, so now it's time to practice some questions. So most of the questions here are PYQs, and some other questions also I have added for the practice purpose. Okay, so first we'll do the question that I gave you in the last class. So you have to convert RCH2 CH2OH to RCH2 CH2 COH, RCH2 CH2 COOH. See, this can be done within one method, that is by using a strong oxidizing agent, but options are not like that. Options I have given you in a different way. So first we need to convert this OH to Br. So what I'll get, RCH2 CH2 Br. Then you can use it with Cn, RCH2 CH2 and then Cn, and then you can do hydrolysis, right? So PBr3 KCN H2H plus. So correct answer for this question is option number A. Okay, fine. Now let us see the question. So most questions are on the acidic order, because previous year many questions have been asked from the acidic order concept. Okay, so we will practice a lot of questions for them. Which of the following orders is not correct? Okay, please see here, is not correct for the in decreasing order of acidic character. Okay, so now if we see, here chlorine is there. Okay, here chlorine is in the first carbon, here chlorine is in the second carbon, here chlorine is the first carbon, and here there is no chlorine. So this order is correct. Next, if you see here, iodine, bromine, chlorine, fluorine. If we know that fluorine is highly electronegative, so this is a better electron withdrawing group. So this compound is having more acidity, but they have given it in the reverse way. So the correct answer for this question will be option number B. Okay. Next, if you see here, there are 3 chlorine, so definitely it will be more acidic because it can withdraw more. Here 2 chlorine, here 1 chlorine, here there is no chlorine. Next, if you see here, HCOH, CH3COH, C2H5, CH3CO. So these are all having plus I effect, right? Plus I effect, plus I effect. So they will be less acidic. Okay, fine. Next, which one of the following orders of acidic strength is correct? Okay. Now, if you see, first of all, this RCOH is obviously more acidic, so that is correct. Now, if you remember, water is more acidic than alcohols. Okay, there is only one alcohol which is more acidic than water, that is your CH3OH. But in general, it is given, so alcohols are generally less acidic than water. So after that, water will come, and after that, alcohol will come. So we can eliminate this option, and we can eliminate this option, and then we can eliminate this option also. So correct answer for this question will be option number C. Okay. Next, which of the following will not undergo HVZ reaction? So if you remember, what is the condition for HVZ reaction? Presence of alpha hydrogen, right? So here if you see, this is the alpha carbon, so there is alpha hydrogen. This is alpha carbon, there is alpha hydrogen. Now let us draw the structure of this one, 2,2-dimethyl propionic acid. So if I'll draw first of all propionic acid, and then I have 2,2-dimethyl CH3, right? So if you see here, there is no alpha, this is an alpha carbon, but there is no alpha hydrogen here, right? These are your beta carbons, right? So there is no alpha hydrogen, so this one will not show HVZ reaction. Okay. Next, what is Q in the following sequence of reaction? So first we have 4-methyl acetophenone. So let us draw this one. We have 4-methyl, this is acetophenone, and on the 4th carbon we have 4-methyl acetophenone. Then if you do KMNO4 and then KOOH, so that means this one will also change, this one will also change, so we will get here COO minus K plus, and here also I will get COO minus and K plus. Now if you treat it with H plus, dilute H2SO4, so we will just get here, one second, yeah, we will get COOH group on both sides. Right. So this is what? This is your terephthalic acid. So this compound is called as terephthalic acid. Okay. Next, which one of the following reagent would bring the following transformation? RCOH to RCH2OH. So just now we discussed we can do this in presence of lithium aluminium hydride in ether or in presence of B2H6. Okay, so you can just revise the reagents. Correct answer is option number D here. Okay. Next, which of the following is the correct sequence of relative acidic strength? Again, acidic strength you see here. We have fluorine, chlorine, bromine. Here we have chlorine, bromine, fluorine, bromine, chlorine, fluorine, chlorine, fluorine, bromine. All of you know fluorine is highly electronegative, so it will be having a greater electron withdrawing power and it can stabilize the conjugate base better, right? So the correct answer for this question will be option number A. Okay. Next, among 2-chloropropanoic acid, 3-chloropropanoic acid, 2,2-dichloroacetic acid and propanoic acid, the Ka values will be in the order of. Okay, so let us first draw the structure. 2-chloropropanoic acid. I'll just draw the structure like this. This is 2-chloropropanoic acid. Next we have 3-chloropropanoic acid. So you have like this 3-chloropropanoic acid. Next 2,2-dichloroacetic acid. So you have 2,2-dichloroacetic acid. 2,2-dichloroacetic acid, and then we have propanoic acid. So we have propanoic acid. Okay. So you see here propanoic acid is not having any withdrawing group, right? So definitely propanoic acid will be least acidic, right? So if it is least acidic, then its Ka value will be least. So you can see here propanoic acid is least, here propanoic acid is least, here also propanoic acid is least, but here you can see there is, so we can eliminate option number D. Okay. Next, if you see here there are 2 chlorine groups, so definitely this one will be more acidic. So we have 2,2-dichloro here, 2,2-dichloro here, this one is wrong, we can eliminate. Now if you see out of these two, here there is chlorine is more closer to the COH group, so this will stabilize more. So 2-chloropropanoic acid next will be there. So we have 2-chloropropanoic acid, 3-chloropropanoic acid. So we'll eliminate this option and the correct answer for this question is option number A. Okay. Next, which of the following will not undergo HVZ reaction? So if you see formic acid, if I draw the structure of formic acid, this is formic acid. There is no alpha carbon here, so there is no alpha hydrogen also. If there is no alpha hydrogen, then we cannot have this reaction. So correct answer will be option number B. Okay. Next, identify the correct order of boiling points of the following compounds. So boiling point, we have already discussed that acids will have higher boiling point. So the 3-1 will be highest. So we can eliminate option A and C. Now after this one, after your acids, the more next boiling point comes for alcohols, right? So we have 3-1 here also, 3-1 here also. Then it comes for aldehydes and ketones. So 3-1, 2-4. So correct answer will be option number D. Okay. Ethers will have the least boiling point because they do not form hydrogen bonding. Okay, next question. So this is question number 10, the last question of today's series. So you just need to find out, first of all, Br2 and phosphorus is there. So this is your HBZ reaction. So this one will give you this compound, right? So this is Y. Next, what we have? KCN and H3O plus. So this one will convert to Cn and then will again convert to COH. So we'll have CH2, COH, and then we'll have COOH. So now if you remember, morning we have like in the previous class we have discussed OMSGA, right? When there is one CH2, we call it malonic acid. So correct answer will be option number D. Okay. So students, this is a homework question that is given to you. So you have this compound KMNO4KOH. After that it is Br2, FeBr3, and then C2H5H plus. You have to identify D. Okay. So question is identify D. Let me write down the question here. Okay. So the question is identify the D. Okay. So these are the options. So I want all of you to try this question and comment down the answers. Okay, so students, with this we have completed the most important chapter, that is aldehydes, ketones and carboxylic acid, a very high weightage topic for your PU boards also and for your KCET 2025 examination also. So in the next class we will be revising this complete chapter, okay, all the reactions, and we will be practicing a lot of questions here. Okay, so I hope you are enjoying this session and you have made notes for all these reactions. If you have any doubt in any question, any concept you want to be explained again, please comment down. I'll definitely address it. Thank you for watching and stay tuned for the next episode. Do not forget to subscribe the channel and do not forget to join our WhatsApp channel also. Okay, so all the very best for your preparation. See you soon in the next episode of this series.